Hi everyone, welcome to Makers Machining again. We're going to be doing our first cut on our block that we've been talking about, our drill block. I've got the material in the saw here. We looked on the print and it called for 1018 cold rolled steel. So I've got various pieces of material here that we work with, and I'll show you the difference between cold rolled steel and otherwise. Hot roll steel, various alloys and materials that we use. Anyhow, I've got my part set up in the saw, and I want you to focus on the saw cut that's happening, because this is a saw that I've got here. I've got another one behind me here that I'll show you in a second. We're going to focus on the cut. I've put my material in there. I've measured it. I'm a little bit over 6 inches. Our print is calling out for a 6-inch long piece, so I've got the saw set for that. If you look over here on the back side, you'll see the teeth on the saw blade right here. There's some pretty coarse teeth on this one here. We'll talk about that in a second. You can see how coarse those things are. And this saw blade has a variable pitch, so all the teeth are not the same distance apart. They've got various pitches or steps between the teeth. That's so the saw, as it's cutting through, has a better chance to take a cut with each tooth, and it doesn't set up a harmonic vibration to get the saw blade bouncing. If everything's uniform, then you get this harmonic vibration. That's the same with the countersink that we talked about earlier, that some of the countersinks are chatterless because they've got different teeth patterns on them. So anyhow, I'm going to hit the switch and turn this thing on here. I'll try to talk loud enough over this so you can hear what I'm saying. Make sure we're closed up here on our vise. Single cycle. Here we go. So we've got a lot of coolant splashing on there. The saw blade's going through there. I have a variable speed that I can slow down the travel speed of the saw blade. There's a brush over there that knocks the chips out of the blade as it goes through the cut. You want to keep those chips pulled out, so there's a brush that has a rotary motion going on up there that knocks those chips free. As it travels down, it'll go through and make the cut, and then the saw will shut off. If we have a lot of these parts to make, which I anticipate you guys will probably be making some parts as a sample, you'll be making more than one cut. So some saws have a stop that has a finger on. You pull your material out to your stop, and you make your cut. Okay, our cut is finished. I'm going to open up the vise, the back vise, and here's our cut off piece. I've got another one or two laying here from other cuts. What I'd like to show you here, every time you cut metal with whatever it is, you're going to get some kind of a burr on there. And here is a little burr on here. You can feel it, maybe you can't see it, but you want to get rid of that burr for when you put this thing in the vise in the milling machine to clamp it. You don't want to be clamping on the burr, you want to be clamping on the flat side. So what I've got over here is a belt sander that I use to deburr that. So I'm going to turn this belt sander on. This thing here goes in this rotation and it makes a little noise. But when I belt sand just to knock that burr off, I kind of lay it flat and just touch the four sides, and at that point the burr is gone. I might have a little bit of a burr on the end, but that's okay. We're mainly focusing on clamping it. I forgot to do the other end. I lay it flat. There's an art to belt sanding. You don't want to go too high up and down. I always put my part in the belt sander, so if I do have a big burr or something catches, it just bounces the part up. If I'm up too high or if I'm pushing too hard, I could tear the belt, or it could grab the piece, tear the belt. If I'm too vertical, or if I'm holding it this way and the belt catches it, it's going to kick that thing right into my hand, or toss it off the sander or something. So just lay it flat. Don't have to do a lot of pressure on it, just to get that thing to take the burr off. It's all gone now. It's nice and smooth. Okay, so we've got all that cut. We got our length ready to go into the milling machine department and do our end length and everything else. I'm going to show you about saw blades here real quick. They have different kinds of saw blades for different applications, different saws. The saw blade that you see in the machine right there has these great big coarse teeth. Typically the idea is to have at least 3 teeth engaged in your material that you're cutting. So we're a 1-inch square bar. You know, you've got 3 teeth are easily within that 1-inch square bar. If you're cutting thinner material, then you would go to a finer tooth blade. I don't know if you can see the comparison between the two there. This is a real fine tooth blade. These are, I believe, 3 to 5 inches, or 3 to 5 teeth per inch. This here is probably 8 to 10 teeth per inch, and you can see there's a varying pattern on those things, so there's no vibration set up in there. This is a tool steel blade. It's a higher alloy material. Here's another view of some pretty vicious looking teeth there. But there's different grades of steel that they use for bandsaw blades. For a vertical bandsaw, for example, you might have a carbon steel blade that they use. Maybe it's a darker color. This is a used blade. You can see there's been bronze cut with it, and we keep a tag on there. This is a bronze blade, because if you cut bronze with a blade, it doesn't want to cut the steel very well. So we use different blades and kind of keep it for the same material. But this is a carbon steel blade. As compared to high-speed steel, it doesn't last nearly as long. But in a vertical bandsaw, you might have where you're cutting sheet metal or something thin. You really have to be careful when you cut thin material, because just visualize you've got 2 teeth coming through a piece of sheet metal. If you're pushing too hard, or you're getting a dull blade, you could pop off a tooth on the saw blade, and it's like a bullet flying through the air. You got to wear your safety glasses when you're sawing. I forgot to mention that when I first started the saw up. Safety glasses are a must when you saw. But the tooth pattern, if you're cutting thin material, you want to make sure that you feed it slow enough so the blades have a chance to cut the material and not pop off the teeth. Those could be pretty vicious. So you've got tool steel blades, you've got carbon steel blades, and if you don't have a cut-off saw, a horizontal cut-off saw like this, you might have to resort to an abrasive cut-off saw maybe. That's where you get a great big round abrasive wheel and you pull it down and sparks fly, and it gets pretty hot on the material. It will discolor the material a little bit from the heat. There's reciprocating hacksaw machines that go out there, and it's by gravity that it feeds down. Or you get the good old-fashioned hacksaw. So you might have to use a hacksaw to cut your parts. And you know, you might say, I'm not going to cut a piece of I-beam with a hacksaw, but a friend of mine, he grew up in a culture that they didn't have all this stuff, and when he was a kid, he started out, he did the sawing on the material, and he used a hacksaw. So I want to point out the teeth on the hacksaw are all pointed in one direction. So when you run, you can maybe see it. It's real hard to see, but all those teeth are kind of pointed in that direction. So when you saw with a hacksaw, the only time you're cutting is when you push. So you got to make sure you get the blade on the hacksaw right. It's the same with the file. A file only cuts when you push, if you're filing. So it's the same thing. But you want to get that tooth so it's in the cut. You got to make sure your bandsaw blade is on the saw properly, because it could, if it's backwards, it's not going to cut. You see all these bandsaw blades that I've got here are coiled up. I'm going to show you how to do that, and probably be smart if you wear gloves when you do it. But all you have to do is grab the blade, put your toe on the bottom in the center, and you kind of twist it around like this, and bring it together into 3 loops. Those teeth are kind of sharp. Okay, so there you are. You have your bandsaw blade coiled up. To uncoil it, you have to figure out which loop you want to undo, and a lot of times we'll just throw it out on the ground and let it spring open by itself. I want to show you something on this particular blade here. This is a brand new blade, and you see this discolored area right here. This is where they weld the blade together. You might have a saw that needs a blade that's 11 feet 3 inches long in the flat. They'll take it and they make this blade material in a mile long strip. They'll cut a piece that's 11 feet 3 inches long for you, and then they weld it together. They butt weld it together, and we'll see one of these other times where I've got a vertical bandsaw that has a welding attachment on it that it's right on the bandsaw where you can weld your blades together. But the discoloration you've got there's the material here on the saw blade, whether it's a carbon steel blade or a tool steel blade, the material of the saw blade has to be harder than the material that it's cutting, obviously. And the teeth that do the cutting have to be hard. So when you weld a blade together on the attachment on the bandsaw, the two pieces you have to have nice and square. You butt them together, and then there's a lever that you push down, and it butt welds and melts all that metal together. It creates kind of a flashing on there that you have to grind smooth. After you've ground it smooth, then you have to anneal it. Annealing is a heat treating process, kind of, that softens up the material, because the tool steel blade has a lot of carbon in it, and when you weld it and it cools down, it'll be brittle. So annealing it, between there's two jaws that clamp those pieces together when they're welded, you'll get the heat that you transfer into that to get real hot, and it'll turn blue. So that's what that mark looks like. We'll weld a blade together for you in another episode. So anyhow, a saw blade and the tooth. I'm going to measure this here real quick. The band material in this particular one is about 44 thousandths. This is a caliper, so it's not exact measurements. But if you measure over the teeth, where the teeth are, it's 66 thousandths. The teeth are offset, they're kicked out both sides of the band, so the slot that you're cutting, which is called the kerf, is wider than what the band is. That way, when you are cutting, the whole blade is not rubbing in the metal. So anyhow, that's a tooth pattern. I'm going to add here that, you know, any of this talking that I'm doing here, you might say, man, I'm not going to remember all this stuff, and Tim's going too fast. Well, I know I go kind of fast, but go back and replay the video again. I got one more quick thing I want to show you about a cutoff saw here. I've got an old cutoff saw that we use here. Yeah, we used to use. We don't use it much anymore, but I can show you what this thing does. It's another saw that by gravity it feeds down through a cut. This particular saw, you can set and cut angles. So you get your protractor out. Let's say you want to cut a 45-degree angle. You put your protractor in there. You set your protractor up against there, and then you can, I don't have it loose there, I can grab it, but you can kick your back jaw out and lock it down, and then the front part comes and clamps the tube in. I'm going to go around the back side here and show you what I'm talking about here. This saw has a vise that comes and clamps, and it pivots, and you can lock that down, and you can also lock this thing down. You can get whatever angle you want by loosening this thing up and kick your angle, and then your clamping part of your vise will also go on an angle. So once you get the angle you want, you lock this thing down tight, and you can come down and cut and set your angle of your back jaw tight, lock that down, and then you can make an angle cut of whatever piece you need. My other saw that I had there doesn't have that flexible vise like that. So we've been cutting a bunch of round tubes here. There's a pan full of tubes. We cut all kinds of different shapes. You can see some different things I've got here. Some big tubes here, small tubes. Here's a piece of hexagon material. That's something that we can cut off. I would strongly suggest clamping this in the vise this way instead of on the points, because if the saw blade catches, it's going to turn in the vise. So you got to be a little careful with that. Here's a piece of hot rolled steel, and you can see the end of a bar of steel is really bad where they lop it up when it's hot or when it's cold. But this is A36 material. It's got a hot finish on it, whereas our bars that we're going to be doing have a nice smooth finish. It's cold roll, nice crisp corners. Here's again the lopped off end of the bar. You need to get it finished up there. Anyhow, more discussion can follow on this. We'll sign off. I got another little video I'm going to do for you right after this one, and we'll be talking to you again. Don't forget to subscribe and like.